Right, here we go. Session 9, the factor theorem. So we've moved on a little bit from sketching curves and looking at domain and range. And we're moving on to the factor theorem, a little bit of algebra. I think you'll find this one quite fun. And so here we go. Right, so the factor theorem. Now this is really, really useful for when we're factorizing. So useful when factorizing. You could use it for quadratics, but specifically we use it for cubics or even higher, so power of 4, power of 5. So useful when factorizing cubics or higher, which in turn, is useful for solving cubics or solving equations and sketching cubics or quadratics or even higher. Okay, so that's what the point of it is. We're going to start, I'm just going to demonstrate what it is by looking at a quadratic. So I'm going to ask you to, e.g. 1, how would I solve x squared minus 5x minus 6 equals 0? So how would I solve that equation? Okay, there's lots of ways I could solve it, but this one you should hopefully be able to see factorizes quite nicely. If a quadratic factorizes, always go for that method. And then either... Now, what we can say at this stage is x minus 6 and x plus 2, these are factors of the quadratic x squared minus 5x minus 6. They're factors because they're two things that multiply together to give me that quadratic. In the same way, if I had, say, 24, 8 and 3 would be factors, okay, because 8 times 3 gives me 24. It works the same in algebra. So those two brackets times together give me the quadratic. They are therefore factors of that quadratic, okay? Right, now, so if in general, so for this particular quadratic, so x equals 6 and x equals minus 1 would be solutions, okay, or we call them roots. So the solutions or roots are 6 and minus 1. Now, in general, if x minus a is a factor of a polynomial, okay, is a factor of polynomial. Now, polynomial is a quadratic or a cubic, anything that in this form where you've got x's, then f of a will equal 0, okay, and a will also be a root of the polynomial. Okay, now that's the general form. It'll be a bit easier when we look at a specific example. Okay, so e.g. 1. X cubed f of x equals x cubed plus 3x squared minus x minus 3. Okay, now fully factorize f of x. So if fx equals that, I want to fully factorize that. I want to put it into brackets. Now if it was a quadratic, like that top one, we have some techniques for a quadratic. The last number times is, you think of two numbers that times the last number and they add to the middle number. We can't do this as easily for a cubic. So what I need to do is I need to test some values. I need to put some values in, bit of trial and error. So a bit of trial and error to find the first value. So I'm going to test some values. What I mean by that, I'm going to put in, and I'm going to start by putting in 1. Okay, I'm going to put 1 into that equation. Trial and error. I've just picked 1 because it's an easy number to deal with. So I'd get 1 cubed plus 3 times 1 squared minus 1 minus 3. I've just put 1 into the fx equation. If I do that, my answer is 0. Now, it's 0, so I know that's what I'm looking for. Therefore, x minus 1 will be a factor. Okay, that's great. I picked 1. It was a bit of a guess. And it worked. It got me equaling 0, which is exactly what I wanted to do. If it didn't equal 0, I'd have to keep trying until I got a value that did. So I know x minus 1 is a factor. Now I could keep going, testing values, until I've got 3 factors, because I know that it's a cubic, it's going to potentially have 3 factors. But I'm going to do it a slightly more efficient way now, because I've got 1 factor. I know that x minus 1 multiplied by something, and it's going to equal x cubed plus 3x squared minus x minus 3. Okay, so I know that that times something else is going to equal that. Now this has got to be a quadratic, because a quadratic times a linear, that's the only way I'm going to get a cubic. And I've got to try and work out what a, b and c are, because that's basically what I'm trying to work out. Now, the only way I can possibly get x cubed, if I do x times a must be equal to 1, because the only way I'm going to get a single x cubed is if I do x times an x squared. So a has got to be 1. I can get that really easily. C, well, the only way I can get the number minus 3 is by doing minus 1 times c. So minus 1 times c gives me 3. Therefore, c must equal 3, okay? It's got to be. So I know straight away, I can fill in a few of the blanks here. So I know it's going to be x squared plus bx, which is the slightly harder one to find, plus 3, okay? Equals x cubed plus 3x squared minus 3. Now, I want to work out what b is, and then I've basically found the 2 factors, okay? Now, in order to do that, I need to multiply out and I can compare some coefficients. So let's go and do that. So x cubed plus bx squared plus 3x minus x squared minus bx minus 3, and that equals the right-hand side. Like so. Now what I can do is I can group them together. So I've got the x cubed. I'm going to group the x squareds together. So I'm left with b minus 1 x squared. Just take your time to think how I've got that. I've factored out the x squareds. I then do the same for the x's. So it's going to be plus 3 minus b x's minus 3. Now I can compare the coefficients. I know that 3 must equal the bit in front of the x squared. So I know b minus 1 must equal 3. Okay? So b must equal 4. I could have done it with the x's, and let's just check. If I compare the coefficient in front of the x's, I've got 3 minus b equals minus 1, and again the same, you're going to get b is 4, which is great. That's always a good check. So my final answer is, I know it's going to be x minus 1, and the other factor is going to be x squared plus 4x plus 3. That will equal the cubic. And I can keep going because I know, well, I check, can that quadratic be factorized again? And I think it can be. So my final answer is going to be x minus 1. I can factorize this, x plus 3, x plus 1. And that is the cubic factorized. So that's quite a nice way of doing it. So obviously a little bit harder than factorizing just a quadratic. But once you've got the first one and you've worked out what the quadratic is, by comparing the coefficients, you can get it quite easily. Right, we're going to do another example now. So EG2. So given that x plus 2 is a factor of x cubed minus 5x minus 3, find a quadratic factor. Okay, so it's told me what that's the question. It's probably a 3-mark question. Given that that is a factor of the cubic, find a quadratic factor. Right, you might want to pause it and have a go yourself. But I'm going to do the same thing again. I know that x plus 2 multiplied by some quadratic factor is going to give me the cubic polynomial at the end. So it's going to be something ax squared plus something x plus c. So I'm trying to work out what a, b, and c are. That's effectively what I'm trying to do here. I can do the same thing again because I know that I've just got a singular x cubed. So I know immediately a is going to be 1. And then I also know that 2 times c, so 2 times c equals minus 2. C is going to be minus 1. So I've got the 2 easy ones straight away. Right, let's go for the last one now. So I know it's x plus 2. I know it's x squared plus bx minus 1. And that's going to equal x cubed minus 5x minus 2. Let's multiply this out. X cubed plus bx squared minus x plus 2x squared plus 2bx minus 2 equals x cubed minus 5x minus 2. Right, I'm going to group the x squareds again. So in front of the x squareds, I'm going to have a b plus 2. And I'm just going to compare that to my x squareds on the right side. I've actually got 0x squareds on the right-hand side. So comparing the coefficients, the number before the x squareds, I know b plus 2 must equal 0. Therefore, b is minus 2. And I could do a quick check using the x terms. So check using the x terms. My x coefficient, if I compare that one and that one, it's going to be 2b minus 1x equals on the right side minus 5x. So 2b minus 1 equals negative 5. And I get 2b equals negative 4b is the same, minus 2. Okay, so my final answer is x plus 2, and the quadratic factor is x squared minus 2x minus 1. So the actual answer, the quadratic factor of that cubic, is going to be x squared minus 2x minus 1. That times that gives me the cubic. Okay? Right, let's have a look at a slightly different ones. So just a bit, as a little bit of an extension, you might get asked this. So if, let's go for straight in. So show EG3, show that 3x minus 2 is a factor of 3x to the 4 plus 4x cubed minus 16x minus 7x plus 10. Okay. So show that 3x minus 2 is a factor of that. Well, remember, if we put in the root and stick that in, it should equal 0. So if 3x minus 2 is a factor, then f of the root, now the solution of that would be 2/3. So f of 2/3 should equal 0. And let's see if that works. So 2/3 to 4 plus 4 2/3 cubed minus 16 2/3 minus 7 3/3 10. And you can try it out for yourself, but I will save you the hassle. That does equal 0. Therefore, 3x minus 2 will be a factor. So that's another style of question you could get asked. Okay, and you must write that statement at the end. Therefore, 3x minus 2 will be a factor. Okay, so you could be asked those sort of questions as well. Now, the final example before I give you some questions is more of a problem solving. So let's have a look at one of these, problem solving example. And here we go. So given that x minus 1 is a factor of 3x cubed minus 15x squared plus ax plus a, find the value of a. Okay, so given that that is a factor of that cubic, find the value of a. Well, if we know x minus 1 is a factor, then f of 1 must equal 0. So if I put 1 into that equation, I just get 1a there plus a. That must equal 0. Let's keep going with that. So I've got 3 minus 15 plus 2a equals 0. So I've got minus 12 plus 2a equals 0. I end up with 2a equaling 12. A is going to equal 6. Okay? So another classic style question, that one. That could crop up in the calculator or the non-calculator, but that is the factor theorem. Right, I'm going to get you to do some questions now from the textbook. So page 95, I want you to do question 1, part I and then VI. Question 2, part I and then V. And then questions 4 to 8. Okay, these are more tricky, the 4 to 8 ones, problem solving questions. But give it a good go, take your time and take it slow, and remember those concepts that we've talked about in the video. Okay, right, well done guys, you're doing really well, and I will see you in session 10.